Hi, everybody. I'm Richard Liu. I'm from QCT Product Marketing team. In today's session, we're going to have a deep dive into the AI technology, and also we'll discuss about how AI is going to impact our industry and also impact our business. Besides my presentation, I also invite it's our honor, okay, to invite 3 guest speakers from the leading technology companies. The first guest speaker is, sorry, I need to read my paper, okay, so I can pronounce their correct title, okay. The first guest speaker is Ting-Wei Huang. She is the Director of Product Management from Intel AIPG. And the second guest speaker is Nishant Agarwal. He is the Solution Architect from Alibaba. And the last guest speaker, Fraser Gardner. He is the Solution Architecture Director from Nvidia. Okay, so it's my pleasure to have them to join with me to share their idea about their vision on AI, and also share their latest development on AI technology. Okay, and one thing I think is the most important thing here. Okay, I want to highlight. In the end of this session, we will have a lucky draw. Okay, so every one of you has the chance to win a very valuable and very useful prize. Okay, so please stay with us for the next 60 minutes. Okay, thank you. Yeah, so let's start my presentation right now. AI, the artificial intelligence, okay, I think is one of the hottest topics in recent years. We hear people talking about how AI is going to change the world and how AI is going to change our life. Okay, I think it's a little bit, maybe sounds a little bit exaggerated to some people, okay? Because the AI, maybe the AI does not really change our life, but actually AI is already everywhere, and many industries already adopted AI. So actually AI is now, has already changed the way we live, yeah, to some extent, okay? And also we hear the people start to talk about how AI is going to take over our jobs. It's terrible, okay? And definitely it will change our life, yeah. I found a very interesting thing, I just saw a report some time ago. Okay, it's an industry, it's an industry analyst report, okay? It talk about how AI is going to, replace human being, okay, in the future. So he listed the top 10 jobs, okay, which will be taken over by AI in the near future, okay. And the interesting thing is the industry analyst, okay, is on the top 10 list. Okay, yeah, and I'm not joking, I also saw another report, okay, it's about the AI industry, okay. But the interesting thing is that the report was created by the AI machine. The author, actually maybe it's not an author, it's a programmer, okay. He used the AI machine to explore, to search the whole internet, okay, to read through all the articles related to the AI, okay, and he searched more than 50,000 companies related to AI, and then create that report. Okay, so it's very amazing because, the AI machine, okay, in that case, actually can do things much more than a human being can do. Okay, so let's go back to the top 10 job list, okay, to be taken over by AI. Okay, thank God. Product manager, okay, is not on that list. And also, the product manager job, okay, is pretty safe because that report said the product manager won't be taken over by AI even in the long run, okay. So I think, okay, so sorry, above what I said earlier, okay, it's not my point today, okay. I just want to emphasize, AI is already everywhere. Many industries already deploy AI, okay, no matter you are aware of it or not. And also, we expect more and more industry will adopt AI technology in the near future. In the past, I think most of the AI workload was running on CPU. And later on, the GPU, FPGA, and some custom-made ASIC came up, and they helped to offload the CPU and also help to accelerate the AI computing. So right now, for example, all the major cloud service providers are already adopting, or they are considering to adopting multiple types of the accelerator, like the GPU from Nvidia, the FPGA from Altera, and also Intel's coming Nvidia neural network processor, for example. I think undoubtedly QCT is very good at making the top-notch server systems for different applications. And of course, the AI accelerated servers is one of them. Yeah. We work closely with Nvidia to jointly develop the world's first deep learning supercomputer about 2 years ago, which is exactly the Nvidia's DGX-1 system. And also, we joint developed the OCP compliant Big Sur and the Big Basin systems with Facebook for their AI applications too. And in Alibaba's computing conference last year, the computing conference is also called 云喜大会. Okay, Alibaba announced their AGPU server systems with its very unique flexible hardware design. Actually, you can reconfigure the system for different kinds of AI workload. So it is very good to be used for both training and inference. Okay, that system is also made by QCT. So I want to say, actually, QCT can provide a wide range of the optimized hardware for the deep learning usage. Okay, for example, we have the scale-up design to meet the demand for the higher performance for training, both training and inference in data center. And also we provide, we can offer the scale-out design server, okay, for the real-time inference at the edge. Here is our product offering for the deep learning or for the AI. Okay, so you can see our product, especially for deep learning training. Okay, our product can support both the GPU and ASIC, and our top-end system can support up to 16 GPU in a single node. For the inference, I think the single-width PCIe accelerator is already good enough for its purpose. Okay, so we have multiple products, very how to say various products. Okay, to support the accelerators for inference. Especially, I want to highlight for the 1U and the 2U edge compute server. Our design can support the different accelerators like GPU, FPGA, or even SmartNIC. And also, we have the easy to scale out system design to support different CPU to accelerator ratios like 1:1 or 1:2. Okay, so it's very flexible and easy for the customer to configure, customize for their spatial workload. I think if you want to deploy AI to your business, you might encounter some challenges. I think the first challenge is how to label your training data in an efficient way. For example, the labeling data is a very labor-intensive work, okay? And sometimes its cost could be huge. For example, if your data need to be labeled by some professional or by some experts, for example, like you need a doctor to label the X-ray image, for example, okay? The cost might be very high, yeah, because the doctor's time is very expensive. Okay, and the other challenges including how to, choose the right AI models for your to best solve your problem, and also you have to fine-tune your model, and last, even after deployment, you need to you need to optimize the performance to meet your performance requirement. So here I want to give you an example how QCT is helping our customer to speed up their adoption of the AI technology. On this slide, I show the medical image use case. Actually, we have showcased it in many events in the past. Here's an example. Okay, QCT has developed a region of interest image search tool. Okay, by this tool, we can pre-screen the medical image like the X-ray. Okay, and to quickly identify which is the focal spots. Okay, for the doctors to easily label the data. And we have developed an annotator software, annotator tools. Okay, so the doctor can label the data through a easy-to-use, friendly graphical user interface. And in some cases, in order to speed up to shorten your training time, okay, you can consider to reduce the image resolution. Here's an example. Okay, we call it a big symptom. Okay, which means if you want to judge if a patient has the cardiomegaly problem, that means the enlarged heart problem. Okay, actually you can reduce the product image. Okay, in this example, we reduce the product image to 200 by 200 pixel. Okay, because it's a big symptom, so that means reduce the image's resolution won't affect its result. Yeah, so we still got very good accuracy in this example. And in other cases, we call it a smaller symptom, maybe just like a cancer. Okay, you cannot reduce the image's resolution, so you have to maintain a high resolution image. So if you want to shorten the training time, then you have to use a higher performance system like the AGPU server system, so as to increase the computing to reduce the computing time. Okay, so besides those tools we develop and besides those methodology we create for the customers to shorten their process to adopt AI. Okay, and based on our result in this case, okay, we found our AI model can perform 362 times faster than a doctor with 10 years of experience reading the X-ray images. And all of those work was done on our AGPU servers for the training and the 1 GPU server for inference. So Just like I say, QCT is very experienced in helping our customer to adopt AI technology. So why you have to choose QCT as your partner to develop your AI solution? I think the number one, QCT has a very deep engagement with the world's leading company like Intel and Nvidia, and also with the customers, like Facebook or Alibaba. And also we have the AI expert to develop tools to help you, to choose the right model, to help you speed up your process. And finally, as you know, QCT can provide a wide range of different, optimized hardware servers, for the AI, even both training and inference, and also from the cloud in the data center and for the edge. I take the F0D as an example, which is a 9U server based on Nvidia's HGX2 GPU computer platform design, which can support up to 16 Nvidia Tesla V100 GPUs. It's the top end of our AI servers. And also S9C is a 2U multi-node design. With its very unique flexible chassis design, we can accommodate 3 different kinds of slates. One is with only the CPU, no accelerator. The other is 1 CPU plus 1 accelerator. And the third one with the 2 accelerator. With different combination of those 3 slates, we can configure the system, for different kind of CPU to accelerator ratio from 1:0 to 1:1 to 1:2. It's very useful and flexible for the customer for different kinds of workload. So I encourage every one of you to visit our demonstration area so you can check all those products I just mentioned by yourself. That's all my presentation today. So let's welcome Ting Wei.
All right. While they're bringing up the slide, let me introduce myself. I'm Ting Wei Huang. I am the Director of Product Management at Intel AI Product Group. Okay. So, all right, here it is. So I think today and from Richard's talk, we've heard a lot from the industry buzz. You've heard a lot of excitement about AI, a lot of promises, and some might say it as maybe a hype. It feels like a gold rush a little bit. So I think before we jump into the meat, it is important to take a step back and think about where we really are today in terms of AI. In the adoption lifecycle. So this is a survey from Gartner that's done earlier this year. The survey is about 3,000 CIOs. What it says is about 46% of the CIOs says, claims that they've done something on AI, but really only 4% of them really implement them. So what it really means is, there's enormous opportunities still out there for everybody in the room to get together and be able to capture the AI opportunities. And the transformation is happening. Let's look at which segments will be the earliest adopters of AI. So this is kind of how Intel views it, all the industry segments, and we have real use case and engagements with the various of customers in these different segments. The ones that the more on the left we view are more of the earlier adopters in general. These are the segments that have clear use cases with high purchasing powers and high rewards of making decisions quickly and or more accurately by adopting AIs. So what are we doing with it? So our commitment to AI is simple, and our goal is to bring your AI vision to life using our extensive product portfolio. So the first step of AI journey, as Richard mentioned, is to get your data ready. Right? So Intel and our partner ecosystem are here ready to help you with multiple solutions to integrate storing, processing, and managing your data from both hardware and software. And let's look at the stack in the middle. So from the bottom, we have hardware. We have a wide array of hardware that's ready, from data center to edge and also to the endpoint, to do either general processing CPUs. A lot of people may not know, but most of the AI today are actually running on CPUs. We can show you later. And also the middle are the tools. We have tools that target different kind of user personas, from app developers to data scientists to library developers, framework developers, and so on. And then at the end of the day is to help with our industry customers to create solutions that actually solve problems and provide real values. So here's our hardware, general hardware portfolio. So a lot of the AI today are actually done not in deep learnings, which is what we call kind of a classical machine learning use cases. So a lot of those, most of those are running on Xeon or Intel architecture product today. Now on the deep learning side, which is where there's a lot of buzz now, on the mainstream implementations is running on Xeon, and even if you talk, I think there's a Facebook papers that published not too long ago that talk about what kind of hardware they use in their data center for deep learning applications, and it shows that most of the workloads they are actually running on Xeon, both in training and almost 90, if not 100%, are on Xeon. Inference are on Xeon today. Only when you need persistence intensive trainings that a lot of the GPUs are being adopted there. And so on the intensive training side, we have the Intel Nirvana product that's coming in next year. And also on the inference side, we have an array of multiple different products that cover different use cases. So now you say, why do you have so many inference products? You know, how do I know where to use them? So the reason there are so many inference products and so many optimization points is because there are so many use cases, and depends on the products, depends on the data that you're inferencing on, there are different optimization points that you can create a nice product for it. So so before we jump into kind of where the product fits, aligned on the terminology here, edge data center is what Richard focused on, so we'll focus on there as well. So edge is, you know, range from like a local data center or a telco base station tower, or very complex MRI machines, or like a retail workstation as a gateway for your IoT devices out there. So those are what we kind of, the range is broad, and we kind of just call it edge. And the data center is really talking about the hyperscale data center, either from public cloud service provider, comm service providers, or governments, or enterprise IT. So how the product fits at the edge, as you can see, most use cases are you can use Xeon to address. For the dedicated, more media and vision focused use cases, such as surveillance cameras, you can the Movidius, Intel Movidius VPU vision processing units is the best to address that. For the latency bound use cases like streaming, the FPGA is great for that. And then for a lot of more general purpose, basic level graphic or vision specific workloads, then the core processors with integrated graphic would be great. On the data center side, we added the training workloads. As I said earlier, most of the trainings today are done on Xeon. Going forward, as the training goes and more people are doing consistent, permanent, intense training 24 hours at a time, then it's definitely worthwhile to invest in an accelerator like the Intel Nirvana and MP. Okay, so here's an eye chart of all the software tools that's AI related that's provided by Intel. I won't go through all of them, of course, but what you should focus on is the OpenVINO toolkit that we recently launched, which is to helping to develop an inference for app developers to deploy inference models, both at the edge and the data center. And then the other thing is on the deep learning framework side, so we work with framework maintainers a lot to optimize the performance of each topologies and on frameworks that on our hardware. And then we upload it to the framework, to the default framework repo, so to ensure the data scientists, when they're using the framework, they can enjoy the optimizations that Intel had done as well. And for the library makers, Intel ngraph, which is a graph compilers. This will help the people that are writing libraries or create proprietary framework or proprietary topologies to be able to optimize across the broad range of Intel's products, and today even including GPU as well, Nvidia's GPU as well, to be able to not having to do one-to-one optimizations every time when there's a new hardware that come out. Okay, so let's put some myths. So you probably all heard about that if I want to do AI, I have to buy a GPU. False. So first of all, almost all AIs beyond deep learnings are running on Xeon today, and almost all deep learning inferences are running on Xeon, and it will continue to be that going forward. There's an increasing amount of deep learning trainings that, especially in a hyperscale data center like a tier 1 cloud service provider, that are running on using accelerators. The second myth is that GPU delivers significant amount of performance gains, and you probably heard this quote of 100x over a CPU. Again, that's a false. So as you can see on this slide, that claim might be true about 2 years ago, but since in the last 2 years, we've made significant investments both in software and improvements in our hardware. So you've seen about 277 times performance improvements on our inference throughput, and 241 times of performance improvements on our training throughput. So this is actually based on the current Skylake product that's the measurements on the current Skylake products, so which is already out there, and then Quanta has a product with that. And for the next generations of Cascade Lake and the future generation, we're going to continue to see the boost as well. So we're doubling down on AI on our Xeon CPU product line. So as you can see, for Cascade Lake, we add the Intel DO Boost, which is previously known as the VNNI technology, which will increase the the inference performance to another 11x of performance. Okay. All right. So where do you start? So as fellow traveler here, what do you know? Like we see this is a journey. So then in this journey, there will be some inflection points when you're starting, when you're trying out, building new models, where you're trying out whether this AI application makes sense for my organizations. Typically, you start with a proof of concept, and then you probably run it on GPU, and then you get an inflection point and say, let's do the initial deployment. And you can do the initial deployments on GPU, on CPU, or with CPU with accelerators as well. And as you go, if you feel like, hey, this application is really gaining traction, and I have a lot more data, I need to do a very intense training or inference, then you can consider the accelerators, and we will have the accelerator portfolio of accelerator products offer with you and with our partner Quanta here as well. Okay, so last but not least, there is please go to the builders.intels.com website /AI. And if you are interested to know all the use cases that we have worked with our customers on how to implement AI and and to solve their particular problems, we have 30+ public white papers around different industries and different use cases, combining with different hardware and software solutions that you can take as a reference. These are all downloadable on the website. And if you're interested, if you're not in the AI Builder program already, you can contact me or our business development representative out there to learn more about the AI Builder program. Thank you.
So today we're going to quickly cover a couple of use cases that Alibaba has been working on in implementing some of the machine learning and AI techniques. These are pretty interesting projects. A lot of these projects touch services which are quite critical for our society. So we're going to cover those quickly. So this morning we kind of covered at a very high level our services framework, and most of this services framework was first developed within the different businesses that Alibaba operates today. So as an example, we have had image search for a very long time. So on some of our mobile apps, for instance, Taobao, which is one of the biggest ones in China. There's another one called AliExpress. Both these apps have this feature where when you're searching for a product, you can obviously type the product name, but because these marketplaces have so many products, sometimes you just want to search using your camera. And so we have been able to sort of use that, use AI and machine learning techniques to really figure out the features for different product categories, and then really use that to power our product search. Facial recognition is quite an interesting case, and it has had a lot of applications. Last year, Alibaba's affiliated entity, Alipay, launched this feature, which is basically Smile to Pay. So if you go into a KFC, for instance, in China, you will see these automated kiosks where you can literally place your order on the screen, and then you don't even have to interact at the counter. And then when you make the payment, you simply look at the camera, which is built into the kiosk, and then it will accept the payment. So it's really using your facial features to authorize payments. So obviously, that's a very specific use case there. Some of the other things now that we are working on, so I think starting a couple of years ago, the smart speaker segment really created a lot of craze. And obviously, Alibaba also jumped into that. And so Alibaba created its own smart speaker called Tmall Genie. And it's integrated with all the different features. And the main interaction, of course, is using voice. On our platforms, we have chatbots that are basically there to answer hundreds and thousands of queries that are coming every day. And I think one unique aspect in China, which is not there yet in some of the other countries, is content moderation. In China, the government has a lot of guidelines around what is and isn't permitted in terms of being able to post on social media, or in being able to govern content as a platform. So for instance, if I'm a Facebook here, how do I ensure governance of my content? And so specifically, we have employed a lot of AI and ML techniques to really figure out, like, if there's any inappropriate content being posted, that it be taken down. This has been very helpful for Alibaba, especially if you imagine as a platform, you have to govern IP protection on millions and millions of SKUs. You cannot do that by doing a manual review of every single product. So you have to apply some sort of AI tooling to be able to figure out whether somebody's trying to sell a fake product on the platform. So those were some of the examples. So what we really try to do is we have now opened that up through our public cloud services. We released a product, it's called Pi, which is Platform for AI in short. But really, it's what it's trying to do, and I think one of the themes that we all see emerging now is auto ML is going to be really key in the next 12 months. I personally believe all the public cloud service providers are going to try to automate the entire ML pipeline, and a lot of it's going to be around feature engineering as well. So what we are trying to do, we are trying to move in the same direction. This product really is meant to empower developers and data scientists alike to really explore AI and ML tools. So within our portfolio, this is our branding. We call it ET, which is really sort of like our vertical solutions for sort of like solving different problems. This is just real quickly, I wanted to highlight Pi. Pi gets you, it's not 100% automated yet, and it's on its way. But we do offer some of the core things that you would expect on a product that helps you build AI and ML use cases. So we provide feature engineering. We provide different algorithms which are pre-built for you to use. And the interface is essentially a GUI, so you can just drag and drop a lot of these things. And besides that, of course, some of the other things around data preparation, if you need to do sampling or if you need to sort of do some sort of transformation before you prepare your data for training and so forth, we have built those features in the product as well. So I'm going to talk about what we call as City Brain, which is essentially some of our city solutions. This solution is live in 4 cities in mainland China, or actually more than 4. And outside of mainland China, we are currently running several pilots, one in Macau and one in Kuala Lumpur. And really, the intent here is to kind of empower the city governments to kind of use all the data that they collect, but they're not able to really apply the actual, they're not able to use the value of that data to deliver services to the citizens. So here's one of the older, or one of the first generation pilot projects, which was launched in Hangzhou, which is the headquarters of Alibaba. So we call it a City Brain. The project started in 2016, and the first phase of the project really was around traffic management. So we obviously, just like in any metropolitan city, you have cameras at traffic stops. So how do you use the data? And a lot of that data is unstructured data. How do you take that data and then extract the features and then create some sort of structured or sense out of that data set, and then help different governance functions in the city? So the first pilot was around traffic management, and traffic in Hangzhou, just like any major metropolitan, it's a big issue. So we applied that on how can traffic be reduced by controlling traffic lights or by using other ways, and we were able to reduce it by 11% over the last few years. The next phases of the projects have focused more on specific use cases. So for example, if an ambulance really needs to get to a destination, is there a way we can help guide the ambulance through a better routing system? And one of the advantages that Alibaba has is we also own one of the largest data mapping platforms called AMAP, which has, I believe, over 100 million DAUs now. So we have the extensive data, the GIS data. We can empower all of our partners and all of our customers with that data, and then once we are able to take the data from different sources, then they can start to build all these use cases. So in this case, we were able to take data from different IoT sensors. Another interesting bit here is extracting the sort of like the license plate. So there were a couple of cases where that was used to actually find missing children in China. So again, empowering the government and the police departments with this sort of information so they can really help govern their cities. This is the high-level architecture. I'm not going to go through it in detail, but similar to any other product, the first layer really is to sort of figure out how can you ingest all the data. It could be unstructured data, it could be structured data. And once you have that data, then how can you really make sense out of that data? How can you provide tools and then use that data to create better value-added services? And just a quick look at the industrial solutions. So one of the other things is China, of course, has been the growth engine for the world. I mean, a lot of manufacturing happens there. But I think China is going through a phase where they are now trying to focus more on efficiency. And so in trying to figure out efficiency in manufacturing, there's a lot of scope for improvement. And even incremental improvement can have massive effect in terms of the actual output. So we are working with a lot of companies to kind of figure out how can different manufacturing processes be made more efficient. So in a typical industrial setting, you have different sorts of data, not just from sensors. You could have it from your ERP systems. You can have it from your PLM and SCADA and all these different systems. So how do you, again, take the data? How do you figure out if let's say you're a chemical manufacturer, what is your process? What are your variables? And how do you optimize those variables amongst each other? And then how can you basically make your production more efficient? So just as an example, I wanted to show you one of the companies we work with is Trina Solar. It's one of the major manufacturers of solar panels in China. And they were able to achieve an improvement of 7% by using some of these techniques to figure out how can you make production more efficient. And similarly, we have several use cases. We probably don't have the time to go through these, but if you're really interested, grab me after this, or a lot of this information is also on our website. Just a couple of more examples. So this was quite interesting. I think, I don't know how many of you have been to China, but during holiday season, there's a lot of movement of people. So it's almost been compared to like massive migrations of people because everybody's trying to go home. And so you have a lot of cyclicity in the transportation vertical. So how can we apply machine learning techniques to kind of make incremental improvements in that process? So at the Beijing airport, I think in any airport for that matter, you always have this ripple effect where if one plane is delayed by 5 minutes, then it's going to delay pretty much the whole process in terms of scheduling the gates. I don't know how many times it's happened to me where my plane's been delayed because the other plane, incoming plane, was late, or somebody didn't schedule the gate properly. So even just looking at one singular problem will have a massive incremental effect in terms of making sure people get home on time. This is a logistics case where we essentially created a delivery service, kind of like DoorDash. So you can deliver food, and then the food is guaranteed to get at your door in 30 minutes. I think this is a very complex use case because the delivery, so here the restriction is on the supply side because there's only a limited amount of people who are available during the day to deliver the products. So again, we were able to first figure out all the variables in this problem and then sort of build a solution where we were able to work with all the restaurants and all the delivery people and all the sort of players in the whole supply chain, and then kind of work with them to figure out how can you deliver something, how can you optimize delivery in case there's an event, let's say, or if we expect a slight spike because of a very specific event. Like how do you kind of build your business around such cases? Lastly, I'm going to just quickly talk about DataFin, which is one of our newest products. This is for enterprises really to help them kind of become better in terms of their journey towards digital transformation. So oftentimes what happens, or at least what I've seen from my personal experience, a lot of enterprise software is quite expensive if you're a medium-sized shop. So if you're trying to buy SAP for just like a small manufacturer, it becomes quite difficult. It's not just the cost of the software, but then you have to employ an army of consultants, and it just becomes very tedious. So what we've tried to do is we've really tried to figure out what we have learned through the 19 years at Alibaba, how can we help other companies who are sort of going through a similar journey, and perhaps they don't have the investment of the technical talent. Like, not all companies can afford to have an army of data scientists or an army of engineers to do all this work. So what we have done is we have tried to create this product. It's a data warehouse product, but what it does is it really helps companies kind of define their data from ground up. And what I mean by that is, so as an example, if I am a platform, a digital platform, one of the key metrics that I'm going to look at is my PVs and my UVs and my DAUs and whatnot. So how can we help companies to figure out having those metrics and then making sure that in such companies, nobody's using a different metric? And then if there's a conflict in the metric, then the system automatically figures that out. So we call it one ID, one data, and one service, which is essentially trying to build kind of like a shared center with data that is archived based on the domain. So if I have a domain of customer, all the data related to customer is stored, and there's a very strong metadata management. And then how can that data then serve directly in a microservices-based architecture? It can really help into your business services, which then interact with your front end. So it really helps automate a lot of these things so that as a customer, I don't have to hire a lot of people doing just data cleaning all day. So it really helps me define my metrics, and then I can very easily just plug some of the models, and any business user can sort of do that. And then it really automates a lot of ETL processing, which takes a lot of time. So it really, I think some of our customers, what they've seen a massive amount of value from this solution in terms of having an end-to-end data lineage. If I wanted to track down one particular data element, it's going to be broken down at the most granular level. And having clean data is probably one of the first things I want to do before I want to even embark on any sort of AI or ML type use case. And so this is really the building block for that. And lastly, I will just quickly talk about this use case on how DataFin was applied at a telecom company. This particular company had a lot of silos in terms of data. So even if somebody is trying to do anything related to AI or ML, it's just too much data. And the first thing I'm going to do is I'm going to probably spend like half of my effort just trying to find the right data. I'm going to have to spend a lot of time trying to figure out whether it's the right data. Is there duplication? Is there conflicts? And so on. So what we really did was we were able to use this product to really segment and define domains, and then making sure there's no conflict. So what we call is a common data asset layer. So for instance, if I have subscribers who are only subscribing to my IPTV service, then I have a domain for that. And then once I can create my domain, then I can reuse that domain over and over again in different applications. It could be search, it could be billing, it could be marketing, and so on. So what we were able to really do is, this is what we call as the data mid-end. We were able to create that smartness or that intelligence at that level, and then plug that directly into their front-end applications. So they were able to really use and build further cases from there. So thank you for that.
Thank you, Nishant. Next, I would like to invite Mr. Fraser Gardner, Solutions Architecture Director, NVIDIA.
Thank you. So just while we are waiting for the slides to get up, so I am, as just mentioned, a Solution Architect Director at Nvidia. I focus exclusively on customers that are large, either cloud service providers or large internet, provide large-scale services on the internet. And it's my intention today to just talk about a few things that, that my team and I have been working on recently with some of those customers, to highlight some examples of some real-world things that people are actually working on around the sort of deep learning space. And so I'm going to talk about an example that involves image recognition on video that is actually an automated shopping or frictionless shopping experience, but then also I'll talk about audio or audio voice generation. And interestingly enough, they're both examples of things where people are doing very, very high volume inferencing type activities. And have we got the slides going yet? We still haven't. And I might be doing this without slides at this point. And then the last thing I just also wanted to spend a few minutes on is talking about a brand new product that we just announced last week, which is actually our sort of launching into doing GPU accelerated machine learning as opposed to deep learning. We have been very focused on deep learning up until now. And so we have just recently started to work out how to GPU accelerate some of the ML tasks that are not deep learning based. And so they're the things I want to talk. And how are we doing with getting the slides going? Because I really can't cover it without my slides.
Fraser, we've not been given your slides.
Okay, we're going to go to plan B, because I have it on a laptop.
We can plug your laptop in there at the lectern if you wish. Jeremy, would you please come out and help Fraser?
Yep. So not quite sure what happened there, but that's okay. And you're going to need a dongle. Okay, great. That was the preamble. So one of the things I love my job is it's very dynamic. So, and I can put the clicker down too, so you don't need to worry about that. So I wanted to spend a few minutes firstly talking about automatic shopping. And this is not buying cars, this is automating shopping. And it's one of the big growth areas that we see in AI, and there's a couple of very notable and public examples of this that you will all have heard of. But there's also a lot of lesser examples, and it's everything from people doing entire stores with a completely frictionless experience where everything you do as soon as you walk into the store, you're being tracked by video cameras, and literally you're talking about hundreds of cameras in the store, right down to things that actually just look a lot like, vending machines. And so there's quite a lot of breadth that we see in the automatic shopping. But what I wanted to, before I get into the interesting pieces that Nvidia add to the table on automatic shopping, what I wanted to do is also to spend a couple of minutes talking about why is this even interesting? Because often that's sort of useful to know. And so it turns out that folks that want to go and have an automatic shopping experience, they're interested in essentially three things or three blocks. And one of the most thing they're interested in is the middle block here, which is frictionless shopping. And so why is frictionless shopping important? I'll explain what that means. So they're really trying to get to the point where I will convince you to go to a store because it'll be a very predictable experience. You will not get stuck behind a line. You will go, you will get your thing, and you'll walk out. And that will encourage more, they believe that inherently that will encourage more people to actually go to stores. And so the primary reason people are interested in doing automated shopping and automatic shopping checkout is actually to get more revenue, to get more people to come to their stores. The secondary reason is the one that is on the either two sides of here, which is really around by doing, by automating shopping and by tracking what's going on in the store, you sort of for free get inventory control and shopper tracking. So shopper tracking is very interesting in terms of if you want to work out how do you enhance your shopper's experience in the future. It's the whole thing about pairing goods that people like to buy together, stuff like that. So you get a lot of that information that you otherwise have to gather separately, or you don't get it all. And then loss prevention and shrinkage. So this both is avoid things like shoplifting, because if we're just going to bill you for putting the Snickers bar in your pocket because you don't have to check out, then you just get billed for it. So it's not called shoplifting, it's called shopping. And so that fixes that, and it also addresses the issue of loss prevention in the sort of inventory control line as well. So that's the sort of second most important. But it's interesting that's by far the second most important thing. And then then you can do more detailed inventory analysis. But the last thing it's all about really is about the idea of reducing your labor costs. So it's about improving, and a lot of things in AI in generally have that theme, which we notice is generally things are about actually improving revenue or improving your business intelligence rather than just reducing costs. And there's a lot of focus on it being about reducing costs when that really is often a small part of the equation. So now sort of moving from having talked about why do it, etc. I want to just talk about a couple about things of some technologies Nvidia has to add that help sort of facilitating an automatic shopping experience. And also, in part, and I'll be just really obvious about this, is explain, I'm spending my time talking about things that we do in the inference space rather than things we do in the training space, because I think a lot of people already agree that Nvidia dominates deep learning training. I'm also talking a lot about software and implementation, and very little about hardware, because Nvidia actually has a huge amount of software development and a huge amount of software products that it provides, alongside with our great GPU hardware. And so this core to doing an automatic shopping experience one way of doing an automatic shopping experience are two Nvidia technologies. One of them is DeepStream, and the other one is called TensorRT. And so DeepStream is simply the ability to take in multiple video feeds, through either through IP cameras or through other digitizing devices, and take in these video streams, and then basically decompress and convert those video streams into individual image frames inside the GPU. So the DeepStream software stack will in fact take video and present it as a stream of inferenceable images that are uncompressed and ready to be fed straight into your deep learning framework. So one of the key reasons why you want to do that is if you want to avoid having to have one device that can take your video and decompress it and scale it to the right size, and then once you've done that, you have to move your video to the device that you're going to go do the inferencing on. That's a huge waste of time, and it's a huge sink. So DeepStream allows you to take advantage of the fact that every Nvidia GPU already has video decoder and encoding hardware built onto it. So it uses that hardware to decompress the compressed video streams that come in, present it to inferencing, and then literally it just becomes presented as a series of frames. And it also has the ability to tag, the order the frames come in. So if you detect something on one frame, you can go back and know where in the time sequence that frame came from. And so TensorRT, which is automatically sort of built into the DeepStream framework, TensorRT is the software that Nvidia has developed, which is specifically doing for inference. And so TensorRT, you can take a model that was developed in a DL framework like a TensorFlow or a MXNet or a CNTK or a PyTorch or a Caffe2, and you can have done the training in those, and then you take that and you convert that into TRT. And TRT radically reduces the amount of computational work that needs to be done for inferencing, because all of those frameworks were designed to do training. And you don't necessarily need to do a lot of the steps that you do in training when you go to do inferencing. So, and also TensorRT allows you to reduce the precision. So you can have trained your model, say, as a 32-bit inputs, and then you can actually do the inferencing on, either 16-bit or even on integer. And so that will radically speed up the rate at which you can do the inferencing tasks. And so if you put those two things together, as was an example of a POC my team recently did with one of my customers, was we were able to take in the feed from 40 different video streams. So it's 40 simultaneous video streams were fed into a single Nvidia GPU. Those 40 video streams were unpacked, uncompressed, fed into TRT and inferenced on live. And so we're able to sustain that light. And that was with a single V100 GPU. But it could be run on any of it that happens to be one of our sort of higher end GPUs. But you could do the same thing on any of our GPUs, because one of the other interesting things is a lot of this stuff is actually developed for the very, very low power devices that we do. So we're really well known for high-end PCI cards, but we also, which typically are 200-watt type parts. But we also make some 20-watt type parts as well that go into the embedded market. And they're often the things that get used in things like robotics. So the key thing here is that by combining the two NVIDIA software technologies of DeepStream and TensorRT, you're able to achieve pretty phenomenal rates of actually taking live video feeds and converting them into actually actionable data. So that's that one. And so just moving on to the next one, and again, I just wanted to talk about a few examples. This sort of changing tack completely here. We're now going to talk about speech synthesis. So one of the things that is very, very common in the world we live in is interacting with devices that you talk to and they talk back to you. And so one of the consistent problems that we're seeing with those devices is the techniques that have been used up until now for the generation of their voice have been okay, but if you start interacting with them a fair bit, you end up realizing that their voices are very without inflection. They're very robotic, in fact, and there's a reason for that, because they are actually robotic. And so one of the nirvanas in this area is to make those voices more and more like human voices. And as a good example of this, and a company that's done a ton of work in this area is Google, with Google Assistant. If you've seen the Google Assistant demos, it actually says a lot. And believe it or not, it's not actually, it's actually literally programmed to say and stutter and trip over its words and things like that, because it makes it more real. And so you need to have mechanisms to do that. And the very common mechanisms today work okay for when your device maybe says a short sentence. So you might ask it for how do you get to Quanta in San Jose, and it'll say finding directions. But when you want more detail, it really starts to leave the user flat. So as my customers want to get to the point where, for example, you can ask your automatic device to read an entire book to you, as opposed to having a recorded version of the book, then you really want better quality voice. And so one of the techniques developed to do this is called Wavenet. And up until very recently, Wavenet was believed to be very difficult to do on a GPU, because it's a very sort of cyclic process. So it's not a parallelizable process; it's a cyclic process. And so we recently released an example of a PyTorch implementation that would generate wavenets. And one of the important things to show here is that with this implementation, you are now able to achieve very, very good voice quality. And one of the important points to look here, if you look at the charts, one of the techniques that we're using persistent kernels. So the Wavenet kernels are constantly persistent in memory. And so we reuse them over and over and over again. And so even for large sentences, for large long sentences, we can actually achieve a 24 kilohertz sampling rate, which is actually the target that we see that most of our customers are aiming for, is that around at 24 kilohertz is, you know, sort of like a high-def quality voice. And so we're seeing pretty much all of my customers are looking at adopting this, and they're moving away from like pre-recorded clips and or parametric techniques in the past, which can't do the same quality into this new version. So if you're ever interested in doing computer voice things, Wavenet is definitely something to look at. And then the last thing I want to talk about, changing tack completely, is I mentioned at the beginning that Nvidia last week announced its entry into the GPU-accelerated machine learning and traditional machine learning type activities. And so wanted to just very briefly, and this is, I've got to tell you, this is something I'm not an expert on at this point. I do a lot more in the deep learning space, but we're having some really big interest in amongst my customers in this space. And so this is a thing we've codenamed Rapids, or we've called Rapids, and it comes in 3 modules. So there's the DF modules, or QDF, and QDF is essentially a drop-in replacement for an open source data maintenance library in Python called Pandas. So if you have anyone who uses Pandas, there is now a CUDA accelerated version of Pandas, and it's pretty much just a drop-in replacement. And so if you look at the chart on the right, this is an example of a customer's workflow, and it's the blue and orange sections of the bar charts that are showing that this is the data prep work for a particular type of workload. We have comparing running it on the 4 things are 4 different sizes of Spark Hadoop type nodes, and then the 2 on the right are running it on either a single DGX2 or an HGX2 system, very much like the one that Quanta has outside, or running it on 5 HGX1s networked together. And so there's as you can see, there's a really massive acceleration that you're showing here on the Pandas step. And then the next thing is actually doing ML training, and this is things like random forest type work, etc. This particular one happens to be using XGBoost, so it's gradient boosting, and there's significant acceleration on that phase as well. And the really nice thing about this is run on exactly the same hardware that you can run your AI type applications on. Every example I have talked about today would run on every one of Nvidia's GPUs. And so you can just scale to which one of those you need. So we're not having to pick specific technologies or particular hardware to run a particular software stack. Thank you.